What we have here is a final exam, a sample one from the university I teach at. You'd be expected to complete this in 2 hours. So let's just get started. It says to find the domain. Well, you've got the graph of a function. If you have a graph of a function and you're asked for the domain, use the x-axis to measure how wide from left to right. So we can see we're starting here on this graph from left to right. So it's lining up with 2, the points included. And then it's unbroken and continues like that forever. So I'm using the x-axis to measure how wide it is. And so what I've drawn there in red is the domain. And so what we'll need to do is just read that off like you would a number line from left to right, starting at and including 2, and then it continues on forever. So the domain is selection A. All right, with the next one, we're given a formula. With this formula, it's a rational function. So with rational functions, the denominator is not allowed to be 0. So what is the denominator? The denominator is x minus 5, and that is not allowed to be 0. But for the domain, you have to have the restriction on x. So if I add 5 to both sides of that, you have x is not equal to 5. Now, that's a correct answer, but it's not in the form that we see in the multiple choice questions. So what we need to be doing is, which one of these is x is not equal to 5? What would that look like on the number line? Well, you would not include 5, but you'd have everything else. That's what it'd look like on the number line. Now read that number line off from left to right. So from left to right, I'm coming in from negative infinity all the way up to, but not including 5. So I have to jump over 5. So I have a parenthesis because 5 is not included. And then after we get around 5, we just keep going forever. So that's the answer I need. And that's what we've got for number 2. Number 2 is D. Okay. All right, so now let's look at number 3. So the camera can't compete with my virtual pen and everything else. Sometimes I leave the screen, I disappear. So, what is the domain when you have a function presented like this? The domain will be the set of first entries. Notice if this question had asked you what the range was, it would have been the set of second entries. All right, so I'll answer both of those. The domain, which is what we're being asked for, is going to be the set containing -7, -6, -5, and -4. So the answer to the question that was asked here was A, but you could have just as easily had asked what is the range, and the range would have been that set. Okay, which would have been that one. Okay, and depending on the year, sometimes they'll ask for domain, sometimes they'll ask for range. This time they asked for range. All right, let's keep going. What is the domain of this function? Well, you can see what you have there. That dotted vertical line is a vertical asymptotes. So the graph of the function will approach, but it's never going to touch that vertical asymptote. So if I'm using the x-axis to measure how wide this is, and you can see this arrow goes like that forever, I'm coming in from negative infinity, and I always have points on the graph until I get to 2. And then there are no points on that graph with an x-coordinate of 2, because by definition, it can approach, but it can never touch a vertical asymptote. Excuse me. And then once I get past 2, I'm good. And then I'm measuring how wide it is, and then this function is going to go like that forever. So what I've drawn there in red, again, is the domain. If I read that off from left to right, we're coming in from negative infinity, and we're going all the way up to, but not including 2. So we have to jump over 2. Okay, so That's the answer for that one. Okay, let's keep going. Okay, now I have a radical here. And the rule about a radical, so you'll have like a square root, and then the argument is what's inside. And the rule is that the argument, what's inside, has to be greater than or equal to 0. As long as your radical, your square root, is not the denominator itself of a rational expression, which here it's not. So for this one, what's inside, the argument has to be greater than or equal to 0. Again, the domain has to be what the restriction is on x. So I have to get x by itself there. So if I subtract 1 from both sides, then we have x is greater than or equal to -1. And that is a correct answer for the domain. But if I look at the selections there, it doesn't look like that. So what would x greater than or equal to -1 look like on the number line? Well, you'd start at, and you would include -1, and then you would keep going to the right. That's what it would look like on the number line. If I read that off from left to right, I start at and include -1, and then there. So my answer to number 5 is A. Okay. So I'm back. Now the webcam can't cope when I use the pen. Okay, so when I use the pen, it just turns off. So I'm sorry if it's distracting. Okay, so for the next one, what is the formula for f minus g? So you're given f of x and g of x. What's the formula for f minus g? Well, the formula is going to be the formula for f minus the entire formula for g. So the formula for f is 2x squared plus 2. Then minus, and put it in parentheses because that minus sign has to apply to everything. Students hate to write an extra line, but writing an extra line, oh, I'll remember to apply the negative sign to every term, but they don't. Then we have minus 9. So I'm going to have 2x squared, then minus 2x, and then 2 minus 9 is minus 7. Okay, I want that one there. Okay, that looks like the correct one to me. All right, so the answer to 6 is C. Okay. Let's look at number 7. So there's 50 questions. So we're getting there. They want the formula for f times g. Now that is unmistakably a simple multiplication symbol. That's not a composition symbol. Now when I do that, it's the formula for f times the formula for g. So the formula for f is 2x squared, and the formula for g is that. And guess what? That's as far as you can take that. That cannot be simplified further. You cannot multiply that 2x squared inside that square root symbol. Can't do it. If that had just been regular parentheses, you could have, but you can't if it's a square root symbol. And so the answer is B. Okay. All right, let's continue. Okay. Now, the symbol here is unmistakably composition. That is not a multiplication symbol. So it's f composed with g. So when you have composition, reading that off from left to right, it's the first one evaluated at the second one. So I'm going to have f evaluated at e to the 6x. And so what we're going to do is we're going to rewrite the formula for f, and everywhere there's an x in there, just leave a blank, because now we want to evaluate f at e to the 6x, and so that's what's going to go in here. Okay, so I have the formula, and this is a correct answer, but if you look at the selections, it doesn't look like any of those. Okay. So, what are we going to do? Well, we have a rule called the exponent rule of logarithms. It says if you have a logarithm of something to a power, that power comes out the front. So I'm going to have 3 times, and then that 6x is going to come out the front. Now, the natural logarithm of e is just the number 1, because I'm going to have 3 times 6x times 1. So that's my formula. Okay. And the domain there is, there's not going to be any restriction on x. Okay. And if you weren't positive about that, this one says the domain is 0 to infinity. Okay, so -1's not allowed in the domain. But if I plug in x equals -1 into this formula, it's going to be perfectly fine. It won't make it blow up. So our answer for that is going to be D. Okay. Moving on to the next one. Now it's back to simple multiplication. Excuse me, so we're just going to have the formula for f times the formula for g. So the formula for f times the formula for g. Now, when you have something that's not a fraction or rational expression multiplied by a fraction, it gets multiplied by the numerator. So we're going to have 4 to the x times 1 all over x plus 8, which is 4 to the x all over x plus 8. That's my formula. Okay, so A. Okay. Okay, once again, that's simple multiplication there. So f times g, so it's a formula for f times a formula for g. And so it's going to be x minus 8 times the formula for g, x minus 4. And looky there. I'm quite surprised they left it like that. Usually they will go ahead and FOIL it. So usually the correct selection will look like that. That's the first year I've seen them do that, but never mind. Now that symbol there is clearly composition. So it's f composed with g. Oh, let me do that in black. It's f composed with g. So when you're doing composition, you read through it left to right. It's the first one evaluated at the second one. So it's going to be f evaluated at, and my formula for g is x squared plus 12. Okay. So now I'm going to get the formula for f, and everywhere there's an x, I'm going to leave blank parentheses. Because now I want to evaluate f at x squared plus 12. So that's what I'm going to put in there. I can drop those parentheses now, and I get x squared, and then 12 minus 9 is 3. Now don't ruin it. Don't think you can simplify that further. You cannot. So the answer is going to be A. All right, now just a warning here. If you have a product, you can split them up. But if you have a sum or difference, you cannot do that. You cannot. And that is usually what leads people to the wrong selection there with B, because they think, oh, I can simplify that and split it up. So what I'm doing here in red is wrong. All right, it's not that. Okay, so the answer is A. You get to A and you cannot simplify that further. Okay, now we have this with a number. So you're going to get a number as the answer. So we want f composed with g evaluated at -4. So I'm going to start up here. It's going to be the first one evaluated at the second one, evaluated at -4. Okay. So I need to find out what g evaluated at -4 is first. So wherever there's an x, you replace it with -4. So that's going to be 7 minus 4 inside that square root, so the square root of 3. So this is now f evaluated at, well, g of -4 is the square root of 3. And now what I have to do is go to the formula for f, and wherever there's an x, I'm going to replace it with the square root of 3. And that's it. I cannot simplify that any further. That's going to be my answer. Okay, so your answer is B. Okay. Okay, which graph shows the function that has an inverse? Or the question could be, which one of these is a one-to-one function? So to answer that question, you need to apply the horizontal line test. So if a horizontal line only cuts it at most once, then you have a one-to-one function, i.e. you have a function with an inverse. And you can see this fails. There's a horizontal line that intersects it more than once. That's not invertible. That's not invertible. That's not invertible. This one is. Any horizontal line I care to draw only cuts it, intersects it at most once. So the answer is going to be A. So the answer to number 13 is A. Okay. All right, moving on. Which of the following functions does not have an inverse function? Now, the slow way you could do this is you could put this into your graphing calculator and look at the graphs of them and do the horizontal line test. But if you've done a college algebra course, then we should know, I mean, what's that one going to look like? Well, what are the zeros? The zeros are 9, 20, and 13. So it has x-intercepts at 9, 20, and 13. And it's going to have leading term x cubed. So it's going to have in behavior down up. And it's going to go through, and it has x-intercepts in 3 places, so it must turn back and go through those. And you can see it fails the horizontal line test. Okay. You just have to be careful if you're looking at the graphs of these and you are doing in a Zoom 6 in a standard viewing window, you might only see that. And then you think that it's a one-to-one function because in that viewing window that I just drew in red, it looks like a one-to-one function, but it's not. Okay. So, and then with this final exam question, I've seen it pop up like that many, many, many semesters. So you could put these into your calculator and you would be able to see that they're not that these are all one-to-one. That's a line. And so that's like the previous question. This is going to have a shape like that. Okay. And so that will pass the horizontal line test, but that first one does not. But you just have to be careful about the window you're looking in. If you do a Zoom 6, it will look like it's one-to-one, but it's not. So the answer to that, 14, is A. Okay, now we have to be careful. They've asked you about inverses. So let me make this a little bit bigger. So if you're asked about F inverse, then the number inside here is the y coordinate that you're looking for. So you're looking for a point So what f does is it maps x into y. What f inverse does is it maps y into x. So I'm looking for a point on the graph whose y coordinate is -4. And what f inverse is going to do is map that y coordinate into the x coordinate. So let's find the point. So here's -4, and there's the point. So the point that's on the graph is the point with coordinates 0, -4. So f inverse maps the y into the x, and f inverse of -4 is going to be equal to 0. Okay. So the answer to that one is B. Okay, let's keep going. Okay. They want you to consider this function. Okay, and they want to know which of these is the graph of its inverse. Okay, well, let's look at that one. Let's graph that one. Okay. So I'm going to come over here. All right, I've got some old stuff in there. I'm going to clear that up. I'm also going to turn the plots off, so I'm going to scroll up here and then just press enter. Okay, so I'm going to enter this in. So I want the square root of, so second x squared, of 3x plus 8. And then I'm just going to scroll over one because I want that -2 not to be part of the argument. Okay, that looks good. Now look at the windows here. They're all from -5 to 5 for your x and your y. So I'm just going to click on window, and I'm going to change those limits from -5 to 5. I still want the x scale to be 1. One grid mark is 1 unit. And I'm going to do the same thing for y. I want it on the same scale. Okay. Then I'm going to click on graph. Okay, there it is. That is the function. Now, what do we know about the graph of a one-to-one function and its inverse? They're symmetric with respect to the line y equals x. So I'm going to press y equals, and I'm going to come down here, and I want to also look at the line y equals x. Okay, so what you need to do is to pretend that line is a mirror. And what would its reflection be? And you might have to actually turn your head this way to draw. Okay. But if that's a mirror, then this part of the line, its reflection over here, if it's looking into the mirror, its reflection would look something like that. Yeah. And then this part of the graph, if that's looking into the mirror, if that line is a mirror, I would expect its reflection to look something like that. Okay, so what's in red there is the inverse. Now, let's look at all of these. Okay, it is obviously not B. It's not D. D doesn't look anything like what I drew in red. It's not C. And so the only one that comes near it is selection A. So the inverse is selection A. Okay. Okay. I think I'm going to pause this and go get a drink. Okay, let's move along. All right, they want a formula for F inverse. Okay. Now, what you don't do is just take that and flip it. That's treating it like it's a number, and it's not. It's a function. So, there are 4 steps to doing this. The first step is to, let me write it over here. The first step, oh, it's a 13, sorry. The first step is to write that with the y. Okay. The next step is to swap the x and the y terms. Now, what we have to do next is solve for y. I will see students try and subtract 13 from both sides. You can't do that. All right, if you had that, then that would be the next thing you would do. But you don't have that. You have this. So what you need to do is get rid of the fraction. And I'm going to give myself a little bit more room here. How do you get rid of the fraction? Well, you multiply both sides by whatever the denominator is. Okay, so by design, these cancel. And I'm left with a 1 there. And what I'm going to do here is I'm going to distribute x through. So x times 4y, I'm going to write it with the number first and then alphabetical order. And then x times 13 is 13x. Okay. Now I want to get y by itself. So I'm going to subtract 13x from both sides. And now to get y by itself, well, I have 4x times y, so I'm just going to divide that by 4x, but you've got to do that to both sides. And once you have y by itself, then you have basically found the answer. And so that is the formula for the inverse. Okay, now when I look at the selections up here, none of them look exactly like that. Just remember, if you've got this, you can always split that up. So if I apply that to here, I'm going to have 1 over 4x minus 13x over 4x, and the x's cancel. So that is the formula for my inverse. Oh, and it does have an inverse. If you look at the graph of that, it definitely passes the horizontal line test. Okay. Now, is that the only way you could have done it? No. Let's see. The step here is to swap x and y. Now, what I could have done here was I could have flipped both sides, take reciprocals of both sides. So if I flip x, take its reciprocal, I get 1 over x. And if I flip that one, I get 4y plus 13. Okay. And then subtract 13 from both sides. And then I could swap sides because I do want to get y by itself on the left-hand side. And then to get y by itself, I need to divide both sides by 4 or multiply both sides by a fourth. So dividing by 4 is the same thing as multiplying by a fourth. And here I can just divide that by 4. And 1 over x times 1 over 4 is 1 over 4x. And then, of course, once you have y by itself, then you have found the inverse. Okay, so either way you wanted to do that, it would get you to the correct answer. Okay, but what you don't do is take this and flip it. It's not how it works. All right, let f be the one-to-one function defined by the following set of ordered pairs. Find f inverse of 6. So again, when it's the inverse, that number is your y coordinate. So you want to find the point that has y coordinate 6, and what f inverse will do is it will map that into the x coordinate. And here we are. So f inverse evaluated at 6 will be equal to 17. And the answer is A, 17. Okay, so let's move this up a bit. Okay, we got another formula. Brilliant. Okay, so again, that has an inverse. So if I want to look at the graph, I might start with a, oops, can't stand that, cubed. And then we're going to have plus 15. Okay. And then I might start with a zoom 6. Oh, and I don't want that one anymore. Okay, and I'll start with a zoom 6. Okay, so it clearly passes the horizontal line test, and you could change the window just to make sure. Okay, so I'm confident that that is invertible. So it's not going to be D. So we're going to start with, instead of F, we're going to have Y. Then you swap X and Y. Then you want to get Y by itself on the left-hand side. Okay, so let me subtract 15 from both sides. And the next step would be to divide both sides by 6. So they will cancel. And now I might write it, so I have y cubed equals x minus 15 all over 6. And then I'm not done yet. I want y by itself. And so I have y cubed. And so to get y by itself, I'll take the cubed root of y cubed. But what I do to one side, I have to do to the other side. And so I have that, and once I have y by itself, I'm basically done, because that is the formula for the inverse. And so the answer there is going to be A. Okay, Lagoon Energy provides natural gas to residential customers. They charge a monthly service fee of $12. Okay. So you're going to have to pay $12 no matter what. In addition, customers pay 0.283 per therm for the first 45 therms of gas used. Okay. What's the monthly charge for a customer who uses 35 therms? Okay, so for each of those 35 therms, since it's under 45, we're going to have that. And we did not go over 45, so that is information we don't need in that one. Okay, so if the question had been what's the monthly charge for a customer who uses 65 therms, then you would have had to use that extra information. But we don't have that. Okay, so let's go to the calculator. We'll do the rest. So the monthly fee plus 35 times 0.283. Okay. And dollars and cents, I'm going to round that to 2 decimal places. It'll be $21.91. Okay, so the answer is D. Okay, this is a piecewise function, and the number in here is your x value. So which formula do you use if x is equal to 1? And if x is equal to 1, it does not live in here. 1 is not a number between -6 and -2, so I'm not going to use that. But if x is 1, it does live between -2 and 3. Okay. If x is 1, it is not a number between 3 and 6. So if x is 1, I'm going to use that second formula. So the formula is x plus 3, and now if I evaluate h at 1, wherever there's an x, I replace it with 1, and I'm going to get the number 4. Okay. Students who choose this have no idea what a piecewise function is, and they just plug one into every formula. Okay, so there's always that kind of bogus selection every year. Which of the following functions is odd? Okay, well, you could put it in your graphing calculator and look at it. Because what does an odd function look like? If you take the graph of it and you turn it upside down, you get exactly the same graph. Okay, I mean, there is a formula that will give you the same formula as that, and it's tiresome. It's going to be that, because that's going to be, well, you negate everything. And apply the negative sign to everything. And then that's going to be, everywhere there's an x, you replace it with negative x in the formula. And if I raise it to an odd power, the negative sign stays. And 6 times negative x is that. These are the same. And so I'm done with the first one. Okay, that's using the book rules. You can just look at the graph. Let me get rid of that. 5x cubed plus 6x. Oops. I've got an old 83 plus, and it's just the best thing. I understand that people don't use 83 pluses anymore, but it doesn't have that problem with the exponent. Anyway, okay, here we go. Let's do a zoom 6. Okay, now let me just play around with this window a bit. Instead of negative 10 to 10, let me do negative 2 to 2. Okay, now, if you could physically take that picture and turn it upside down, which I might do, you will get exactly the same graph. Exactly. And that's what an odd function looks like. That's a property of an odd function. Let's see if I can just find some blank place to do it. Ugh, it's taking so long. All right, now I'm going to take that. I'm going to turn it upside down. And you see, you get exactly the same function, the same graph. So that is an odd function. That's how you tell what an odd function is, just by looking at the graph. I think that's an easier way to do it. Let me cancel that and let me just, I might need that again. Okay. All right. Jacob leased a car for 3 years for $9,000 with a mileage limit of 24,000 miles. For every mile over the limit, he pays a fee of 20 cents per mile. What would Jacob's total cost be if he drove the car 38,000 miles? Okay. All right. Well, he's got to pay 9 grand. And it's got a mileage limit of 24,000 miles. So for every mile over the limit, he pays 20 cents per mile. So he's driven this thing 38,000 miles. So that's going to give me the number of miles that he went over 24,000 miles. And then for each of those miles, he's going to pay 20 cents per mile. And so I'm just going to put that in the graphing calculator. So let me get out of here. So 9,000 plus, then parentheses, 38,000 minus 24,000 parentheses, and then times 0.2, or you could put 0.2 in parentheses. Okay, so he's going to end up paying $11,800. Pays $11,800, then at the end of 3 years you still have to turn the car in. I don't see the appeal of leasing a car, but never mind. All right, the graph of f of x is shown. Choose the graph of f evaluated at x minus 1 plus 3. Okay, so we've got the plus 3 on the outside here. And that means you're going to take the graph of f and you're going to go up 3 units. But now inside the parentheses, x has been replaced with x minus 1. And that means that you're going to go right 1 unit. All right, so the horizontal one, a lot of people get confused over the horizontal one. The vertical one does what the symbol says. Plus it goes up, minus it goes down. With the horizontal one, it's the exact opposite. So I'm going to take f. So here's the graph of f up here. And we're going to go right 1 and up 3. So our shifted one should look like that. Okay, and out of these selections, that's going to be this one here. All right, so even though I didn't draw it so great, it's going to be selection A. Okay. All right. Which of the following functions is even? Okay. So if the question had been which of them was odd, remember what the test was for odd? You take the graph and you turn it upside down, and if you get the exact same graph, it's odd. So that picture at C, that is an odd function. But we haven't been asked for odd, we've been asked for even. What's the test for even? Well, for even, an even function, the graph is symmetric with respect to WRT, the y-axis. So the y-axis acts like a mirror. And so if I come here to this one, so pretend that the y-axis that I've just drawn in red there is a mirror. And if I've got this part of the graph gazing into the mirror, its reflection would be what we get on the other side. So this graph is symmetric with respect to the y-axis. It acts like a mirror. That is the graph of an even function. So the answer is going to be B. Okay. So the answer is B. This is not, that's not even. Because if I start on this side, what would its reflection look? It would look something like that, which is not what you get. Okay, same thing, the reflection here would look like that. That's not what you get. And the reflection on this side would look like that. So the only one that is symmetric with respect to the y-axis, where the y-axis acts like a mirror, is B. B, B, B. Okay, with number 26, we have been told that we have assume that the relationship between D and P is linear. So we are going to be using linear regression. So we have the price. That's going to be our list 1. So this is paired data. So you can think of those as points. And list 1 will be my x values of the points, and list 2 is going to be my y values of the points. Okay, so what I'm going to do is I'm going to come over here and press enter. Oop, I've got stuff in my list. So I need to clear out list 1 and list 2. So I'm going to come down here and clear out list 1, second 1, comma, second 2, comma. Okay, and then stat and enter. So I need to scroll over to list 1, and I'm going to put my price values. You have to be really careful when you're doing this. 29. Because I'm doing this with an emulator, a mouse, and it can really be. So I'm always double check, always. It just takes me a little bit longer. I might put the video on hold if my list were bigger, but I think I can. 9.7. Okay, now I'm going to double check. Okay, good. All right, so we were told to assume that the relationship is linear. Okay. I don't need to look at a scatter plot on this. All right, so I'm not going to waste time. I've been told it's linear, so I'm going to get out of here. I'm going to press stat, I'm going to go over to calc, and I'm going to find linear regression. Now, my X list I put in list 1. My Y list I put in list 2. The frequency list, you leave that blank. Now, I'm going to store the regression equation in my calculator. So to do that, I'm going to click on vars. Then I'm going to scroll over to Y vars. And then I'm going to press enter. And I'm going to press enter again. And it's going to store the regression equation as Y1. So instead of calling it F, it's going to call it Y1. And I'm going to press enter, and then we're going to calculate. Okay, so I don't have to write the regression equation. The regression equation has been stored as Y1. Now, use the model, i.e. the regression equation, to find the expected demand when the price is 34 euros. Now, the price is an X value. So, when X is equal to 30.4. So you want to evaluate this function at an X value of 30.4. And that's what I'm going to get my calculator to do right now. Okay. So I'm going to come over to calculator, and I'm going to click on vars. I'm going to go to Y vars, and then press enter. And I'm going to choose Y1 because that's where it's been stored. And then I'm going to supply the parentheses, Y1 evaluated at 30.4. And close parentheses. Okay. And then we are going to look at the answers. All of the selections there have been rounded to 1 decimal place, so we don't round until the very end. And that 4 there will not change the 4 here. So our answer is going to be 13.4 kilograms. So we have to make sure we're rounding correctly. Okay. And so the answer is D. All right. Now the next one, let me write that a little bit bigger. I actually don't need to use properties of logarithms to solve that, because I can rewrite, now the base over here is 3, so I can rewrite 9 as a power of 3, which is what I'm going to do. And there's a nice property called the uniqueness property that says if you have single bases on each side of this equation, which we do, then their exponents are equal to each other. And now that becomes a really easy calculation to solve for x. I'm going to add 26 to both sides. And then I'm going to divide both sides by 4. And so I have x is 28 over 4, which is 7. So the answer there is 7. Okay. Now, with 28, number 28, I can't do that like I did in 27. I cannot rewrite 6 as a power of e. So what we're going to need to do is to do a conversion. So here's your base, and there's your exponent. And what's left over is going to be your argument. So we're going to have the logarithm at base e is equal to the exponent, which is 8x, and then the leftover bit is what goes in here. Now, if your logarithm is base e, then the shortcut is ln. Now, we've been asked to solve this for x, and we have what 8 times x is. So to solve it for x, divide both sides by 8. So this is my exact answer. That's my exact answer. Okay. They give an approximation, so I'm just going to come over here and ask it, what is ln of 6? Then divided by 8. Now, all of those answers are taken to 2 decimal places. And of course, if I take this one to 2 decimal places, again, the 3 doesn't have any effect there, and so my answer is going to be 0.22. Okay? All right, solve this equation. Well, I see the quotient rule, which is what I'm going to use. So again, let me write it a little bit bigger. So the quotient rule says if you have a difference of logarithms and they have the same base, you can combine them into one logarithm. And the one that comes first goes in the numerator, and then that one goes in the denominator. Okay, now what? What I'm going to do now is I'm going to convert that into exponential form. And to convert that into exponential form, then it's going to be the base raised to this power. All right, so I'll do it up here, is equal to the argument, whatever is inside the parentheses. Okay. So now, let me make some more space. I have to solve that for x. What you cannot do is say that those x's cancel, and I'll see that a lot. You cannot do that. You're meant to solve this for x. What do you do when you have a fraction and what you want is part of the denominator? Okay, get rid of the fraction. How do you get rid of the fraction? You multiply it by whatever the denominator is. But what you do from one side, you must do to the other. So by design, this cancels. And so what I'm going to do now is I'm going to subtract x from both sides. So they cancel. 25x minus x is 24x. And now to get x by itself, I divide both sides by 24. So the 24's cancel. And I have that. Okay, and that's what we have there. Okay, so the answer is going to be D. Okay. All right, the number of bacteria in a culture is given by that model, where T is the time in hours. Find how many hours it takes for the original population to double. So let me rewrite it out here. And find how many hours, so find T, when the amount after T is twice what you started with. And what is the starting amount? The starting amount is always what's out in the front there. Now I have two expressions for n of t, and so I'm just going to put them equal to each other. And I'm going to leave it like that because you're going to see why. So straight away, we have that the 166's cancel. And so I'm left that. Now I'm going to do the same thing to both sides. The base here is e, so I'm going to take natural logarithms of both sides. Now I'm going to use the power rule for logarithms. It says if you have a logarithm of something to a power, the power comes out the front. And what we're going to get on this side, the power comes out the front. And then I have times ln of e. But ln of e, the natural logarithm of e, is just the number 1. So I'm going to have 0.085 times t times 1. So I'm just actually going to take that off now. And how long? Find t. So to find t, I'm going to divide both sides by 0.085. And so those cancel. And this is my answer. How long will it take? It will take natural logarithm of 2 divided by 0.085 hours. So to find out what that is, because you can see the selections up there, I'm going to put that in my calculator. So ln of 2 divided by 0.085. Okay. And all of these selections there are taken to 2 decimal places, and if I take that to 2 decimal places, that 4 doesn't have any effect, so it's going to take 8.15 hours, and so my answer is going to be C. Okay. All right, how are we doing for time? All right, we're almost coming up to an hour. This is a 2-hour test, and so there's 50 questions. I should have gotten to 25 by this point, and we've answered 30, so you know we're making good time. All right, the pH of a chemical solution is related to the hydrogen ion concentration according to this rule. So yeah, it's just pH is equal to that. Okay. And then it says, what is the hydrogen ion concentration corresponding to a pH of 12? So that's going to become a 12. Okay. All right. I might swap sides. And now I'm just going to multiply both sides by -1. I think. And those negative signs will go away. They cancel. And 12 times -1 is -12. Now, if it's log on its own, the base is 10. So I'm going to write that in there. And now I'm going to convert that into exponential form. And this is why I like to have the logarithm written on the left-hand side. So to convert that, the base raised to this power is going to equal the argument. So 10 to the -12 is equal to h. And so what is the hydrogen ion concentration? It is h, 10 to the -12. And so the answer there is D. The answer to number 31 is D. Okay. All right, moving along. That's a complex number problem. Okay, so let's just do it. So I'm going to have 13 times 8 and 13 times 18i. Okay, so 234. So plus 234i. Then plus 7i times 8, so plus 56i. And then plus 7i times 18i. Okay. Well, 7 times 18 is 126. And then you have I times I, which is I squared. Okay, so I'm going to have 104 plus, and then I'm going to put those two terms together. So plus 290i. And then I squared is equal to -1. And then I'm going to have 104 minus 126, which I'm going to do like this. So 104 minus 126 is -22. So if I have it in standard form, the real part plus the imaginary part times I'm going to get that. And so that's matching up with selection A. If I didn't make any mistakes. Okay, that is matching up with selection. Okay, so get rid of that. Okay. Divide that polynomial by x minus 5. I'm going to use synthetic division. So it's x minus the number in the box. So a 5 goes in the box, not a -5. And then I need to have my coefficients and make sure every power of x is represented. So I have 1 times x cubed plus 2 times x squared plus 4 times x plus 5. Then I draw a line down here. 1 times 5. Then I add 7 times 5. Then we add. And 39 times 5. And then we add. Okay. Now, this is my remainder. This is that's the coefficients for my quotient. So, the polynomial p of x is equal to the divisor times the quotient. And if I start here at the line, there's my constant, my coefficient for x, my coefficient for x squared. So my quotient is going to be 1 times x squared plus 7x plus 39, and then plus the remainder. Now, if I look at the selections, none of them look like that. That's one way I could have written it. The other way is to divide every term by the divisor. You're taking p of x and you're dividing it by x minus 5. Because here the x minus 5 terms cancel. So my answer is going to be, after cancellation, x squared plus 7x plus 39, and then plus this 200 over x minus 5. Okay, so that's matching up with selection B. Okay, now, according to the rational zeros theorem, what is a complete list of the possible rational zeros? Okay, so by the rational zeros theorem, we're going to have plus or minus all of the factors of 10, all over all of the factors of 3. Now you want every fraction that you can form. So I'm going to have plus or minus out the front. So suppose, let's start, suppose your denominator is 1, then you would get 1 over 1, 2 over 1, 5 over 1, and 10 over 1. Now suppose your denominator is 3, you get 1/3, 2 over 3, 5 over 3, and then 10 over 3. And you'd have plus or minus, so you have twice of those. And there we go. All right, that's our answer. Okay. Now, find all of the zeros of that polynomial. Okay, look at it in the graphing calculator, because real zeros happen at x-intercepts. So I'm going to look for the x-intercepts, and this has degree 3, so there will be at most 3 x-intercepts. And so let's have a look. Sometimes the graphing calculator will give you the complete answer. Other times it'll give you a partial answer. So let's see what's going on. I'm going to put in x cubed, then minus 5x squared, then minus 3x, then plus 15. Okay. All right, now I'm going to start with the zoom 6. Okay, I don't need this over here. So I might adjust a window. Let's go from -3. And I might stretch out that my y values just to make the graph prettier. Okay, now we can see I'm looking for x-intercepts that are nice. And we have an x-intercept at 1, 2, 3, 4, at 5. So 5 is a 0. Okay, and we did not have an x-intercept at -5. So -5 is not a 0, so it can't be C. Okay, so I've got it down to these. All right, now I have 3 distinct x-intercepts. So I will have 3 distinct zeros. So it's not going to be that one. And this one says the zeros are 5, 3, and -3. So I should have an x-intercept at 5, 1 at 3, which we do not. And another one at -3. And then now this makes complete sense that it would be this one, because what is the square root of 3? It's about 1.75. It's close to 2. And there's an x-intercept, and it's very close to 2. And then the negative of the square root of 3 is very close to -2. So just going from the graph alone and the fact that this is a multiple choice question, the only thing it could possibly be is A. I'm done with that. Okay. Okay. The polynomial does not have degree 4. The polynomial has degree x to the first plus x to the second plus another 2. So that polynomial has degree 6. So it's not going to be that. Okay. So it's not A. The graph of the polynomial touches the x-axis at x equals 3, and then it turns back. So what are the zeros? You can see 0 is a 0, -3 is a 0, 3 is a 0, and 11 is a 0. So it cannot be C because it says that -11 is a 0, so it's not that one. And this is a polynomial function. The domain of all polynomial functions is -infinity, positive infinity. But what happens at 3? So 3 is a 0. And what is its multiplicity? Its multiplicity is 2. 3 is a 0 with multiplicity 2. If it has even multiplicity, then it touches and bounces back. So the true statement that we're looking for is B. Okay. All right. You can try looking in the graphing calculator, but end behavior is determined by the leading term. And that's our leading term. And our leading term is a negative number times x to an odd number. And if you have a negative number times x to an odd power for your leading term, then your end behavior is going to be up, down. So there's like 4 cases that you need to memorize. If it's a negative number times x to an even power, the end behavior is down, down. If it's a negative number, if it's a positive number times x to an even power, end behavior is up, up. And if it's a positive number times x to an odd power, then you're down, up. So up to the left, down to the right, the answer would be B. Okay. You can try putting it in your graphing calculator. Sometimes you'll have a nice window where you can see it. Other times you will not. So I just memorize the 4 cases. Each of the following images shows a graph of a function. Which could be the graph of a polynomial function? Okay, well, it's going to be that one because we should be able to see it's the graph of x cubed shifted. Okay, but this one is not because it has a corner. This one's not. That looks like the graph of an x squared function. This one's not. In fact, it is the graph of f of x is the square root of x. It's not because it's not the right domain. The domain is 0 inclusive to infinity. And polynomials have domain negative infinity, positive infinity. Same thing here. It looks like it's got, this looks like an exponential function, that it's got a vertical asymptote it's approaching there. So A would be the one for that. Okay. Now you have to know the rules, okay, that I did for the previous one. Okay, this has in behavior up, down. Okay, so if it has in behavior up, down, then the leading term is a negative number times x to an odd power. So the degree is odd. And the leading coefficient is negative. Oh, there we go. There is no formula to put in your calculator. You have to know the 4 cases. Excuse me. Use a graphing calculator utility to approximate the real zero. Okay, so let me write it bigger. Okay, so it says to use the graphing, because look at the selections there. You're going to have to know how to do this in your graphing calculator. All right, so let me get out of here. Let me get into there. Let me clear that out, and I'm going to enter that in. So 4x cubed plus 9x squared plus 9x plus 5. Okay. Yeah, looks good to me. And then I'm going to start with a zoom 6. Okay, so if you eyeball that, it could be any of those. You cannot tell the difference there. So what I'm going to do is I'm going to press the second key and then the trace key. And I want the x-intercept, which is the same thing as the 0. So I'm going to come down here. I'm going to look for an x-intercept. Now, what you have to do with that flashing ball is you can only use left and right scroll. And you need to use the left scroll until that ball is to the left of where the x-intercept would be. Don't think in terms of up and down because you can only use left and right scroll. Now on the graph, so here my arrow, I'm pointing to the x-intercept. On the graph, that is technically to the left. I know it's below, but only think in terms of left or right. So it wants a left bound. So I want to move that flashing ball to where it's just to the left of where the x-intercept is. So I'm going to press enter. Then it's asking me for right bound. So I'm going to use the right scroll and move that flashing ball just to the right of where the x-intercept would be. That looks pretty good. I'm going to press enter. Then it says, do you want to make a guess? And it depends on how sensitive the window is. Like if I move that to the left, I mean, that's a pretty good guess of where it actually is. If you don't want to, you can just press enter again without moving the flashing ball. But this one, I'm going to press enter. That's a pretty good guess for where it actually is. And this is telling me what the x-intercept is. it's telling me that it's calculated the x-intercept to be that. Of course, that means that the 0 is what the x-coordinate is, minus 1.25. And that's going to give me selection D. So that's the answer for that one. Okay, we're almost done. We don't have much longer. Okay, so that completes question 40. We got 10 more to go. Solve the systems of equations. All right. So, you know what? I might take a screenshot of this one and solve that over here. Okay, so I'm going to rewrite that. I'm going to subtract 2x from both sides. So I get that. Then I have both of these expressions equal y. So they're both equal to each other. So I'm going to put them equal to each other. Okay. And then I can solve anything if I can solve a quadratic if it's equal to 0. So I'm going to subtract 7 from both sides, and then I'm going to add 2x to both sides. So I'm going to have x squared plus 10x. Those go away. And 31 minus 7 should be 24. Okay, now you can either use the quadratic formula to solve that for x, or you can just factor it. When it's x squared, I try and factor it. Two numbers that multiply together to give you 24, but at the same time they add up together to give you 10. And yeah, 6 and 4. And then now I can see what the answers are. So, one solution has my x-coordinate being -6, sorry. And the other solution has my x-coordinate being -4. And you know what? As far as multiple choice questions go, looks like it's going to be that one, yeah? Because that does not have the correct x-coordinate. That only has one. Well, it might be -6 puts me there, but no, they put -6 as a y-coordinate. And again, that does not have a correct x-coordinate. So I'm thinking C is going to be the answer. But anyway, let's get the y-coordinates now. So y is going to be 7 minus 2 times your x value. So y is going to be 7 plus 12, y is going to be 19, and so I do have -6 comma 19, and that works for that one. And then if I do the same thing here, y is going to be 7 minus 2 times x, and my x is -4. Oh, my dogs are howling. Then I'm going to have 7 plus 8. And so I get the point -4 comma 15. This sounds pitiful. Okay, they were barking at the neighbor, so I brought them in. They don't like that. Okay, so yeah, -6 comma 19 and -4 comma 15. So the answer to number 41 is C. All right, so C. Okay, so let's go back. Okay, Nikki bought. Might do that on a blank sheet of paper as well. Okay. Let's go to here. Okay. All right. Okay. Well, Nikki, so let's let X be an apple and let's let Y be the price of a banana. So Nikki gives me a formula. 4 apples plus 3 bananas equals $4.30. But I'm just going to write that 4.3. And then Josh gives me a formula. He bought 4 apples and 9 bananas, and he spent 6.1. So there's my system, and I can write an augmented matrix, or you can do substitution and elimination by hand. You are allowed to use your graphing calculator. So in this situation, I would definitely use it. Okay, so we're going to get out of here. We're going to get into the matrix menu, go over to the editor, and my augmented matrix is a 2 by 3. Okay, and my first row is 4, 3, 4.3. And my second row is 4, 9, 6.1. Okay, that's looking good. Now I'm going to get out, second mode, get back in. Then go over to math, go up to RREF, press enter. Get back into the matrix menu, second X inverse. Under name, select A, so enter, and close off that parenthesis. All right, so this tells me that is my so that's where my equal sign would go. First column are my x values, the second column are my y values. So the first row tells me 1 times x plus 0 times y equals 0.85. So x was an apple, and the price of 1 apple is 85 cents. What we asked for? We were asked for the price of a banana. So the second row tells me 0 times x plus 1 times y is equal to 0.3. So the price of a banana, y is equal to 0.3. The price of a banana is 30 cents. So 1 banana is going to be that. If I'd been asked an apple, price of an apple, the answer would have been D. But for this, the answer is A. Okay. Okay, so okay. Well, that one you just plug in 1. So f evaluated at 1, everywhere there's an x, you replace it with a 1. Now, 1 cubed is 1, so I'm going to have 1 plus 1 plus 6 plus 1. And that's going to give me 9. And in the bottom, I'm going to have, or in the denominator, 7 times 1 squared, which is 7 times 1, which is, 17, plus 8 plus 1. And so it's going to be 17 plus 9, which is 26. Oh, the answer is C. Okay, now let f of x equal that. Find any horizontal asymptotes of the graph. Okay, so look at what's the degree of the numerator. The degree of the numerator is 3, and the degree of the denominator is 3. If the degree of the numerator and the degree of the denominator are the same, you do have a horizontal asymptote. And it is the horizontal line with the equation y equals, it starts life as a fraction, and you have the leading coefficient of the numerator, which is 4, divided by, and the leading coefficient of the denominator, which is 3. So I do have a horizontal asymptote, and its equation is y equals 4/3. let me change the problem. If that had been the problem, then the degree of the numerator is 2, the degree of the denominator is 3, degree of numerator is smaller than the degree of the denominator, and so there is a horizontal asymptote, and it would be the x-axis. Okay. If the degree of the numerator were bigger than the degree of the denominator, there's no horizontal asymptote. But for this one, the degrees were the same, and so that is our equation. What is a plus b? Well, first of all, it will work. I'll have a 3 by 3 plus a 3 by 3, so you can add or subtract if they have the same dimensions. I'll get a 3 by 3. So it will work. And what's going to be up there in the corner? I'm going to have 2 plus negative 10, so I'd have a negative 8 up in the corner. And I am done. Okay, so as far as a multiple choice exam is done, we're done. So I don't want to waste any more time on it. Okay, what is 2 times a? You can multiply a matrix by any number, and what it does is everything gets multiplied by 2. Everything. So the first row is going to be 2 times negative 9, so I'm going to have a negative 18 up in the corner, so that one is not right. And then let's do this one. 2 times 5 is going to be 10, so I'm going to have a 10 there, and that one's wrong. And you will find that this is the answer. You just take every entry and multiply it by 2. So the answer is C. Okay. Now, fair enough, they write none of these. They don't say it doesn't exist. Personal experience, because I've been teaching at this university for like 20 years, they write none of these to cover themselves in case there's a typo. But, yeah. Find the determinant. Okay, now, there is a formula to find the determinant of a 3 by 3 matrix. It's very long. You are allowed to use your graphing calculator in the final. Use it. Because the formula takes a long time, and it would be hard, you're going to make a mistake. So the formula is going to be 9 times the determinant of that matrix, then minus negative 5 times the determinant of that matrix, then plus 7 times the determinant of that matrix. And then you work out the determinant. No, this is the 21st century. We're going to use our calculator, okay? So let's define this matrix in our calculator. Second, get into the matrix menu, go over to the editor. We have a 3 by 3, and I'm just calling it A because the letters don't go down to M. So I'm just going to overwrite everything. You have to put them in row by row. Now always check before you exit this screen. I like to check the columns because I've just entered the rows. Oh, I didn't mean to do that. See, it's an emulator I'm working with. Okay, and first column looks good. Second column looks good. Okay, so I'm happy with that. So get out, second mode, get back in, second x inverse, go to math, and it's highlighted on determinant. Press enter. Get back into the matrix menu, and under names, just choose A, which is what I called it, and then close out that parenthesis. Okay, and so the answer is selection A. Okay. All right, now find the area of the triangle in square units. We have 3 points. So the area, again, I might do this one over here. And let me get onto the blank document. There it is. Okay, so the area is going to be 1/2 times the absolute value of the determinant The determinant of what? Well, the first row is going to be, oh, what happened to my, there we go. Let's get the problem up. The first row is going to be my x coordinates. So 1, 3, and 9. The second row is going to be my y coordinates. 8, 4, and 7. And then the third row is going to be just all ones. All right, this is one way you can do it. Another way that some other books do it is the first column is your x values, the second column is your y values, and the third column is all 1. You'll get the same determinant. So let's first of all define this matrix, the red, blue, and the black row entries. So second x inverse, go over to the editor. We have a 3 by 3 still, and now just overwrite. So that's my first row, then my second row, and then my last row, 1, 1, 1. And now double check. All right, and the columns look good. Okay, so I'm going to get out. I'm going to get back in. I'm going to go over to math, and it's highlighted on determinant. I'm going to press enter, and then get back into the matrix menu. And I stored that matrix as A, so I'm just going to press enter, and then close off the parenthesis. Okay, so the area is going to be 1/2 times the absolute value of 30. And of course the absolute value of 30 is 30, and 1/2 times 30 is 15. So my area is going to be D. The answer to that is D. All right, we're almost there. We're almost there. Okay, so let me... Okay, now if you know how to do matrix multiplication, you've got enough there to do it quickly by hand. Okay, because, and I like to define all of my matrices with capital letters. So that's going to be a capital B. So A is known, and A has an inverse. So I need to find X. If I'm solving this matrix equation, X is the only unknown. So to get X by itself, I'm going to multiply the left-hand side by A inverse, but I'm going to multiply this other side by A inverse, but you must do it on the left-hand side. Okay, because matrix multiplication is not commutative. So when I do that, these cancel. It gives me the identity matrix, which X like the number 1. And so this is going to be my matrix X. And I have been told what A inverse is and what B is. And I can do that really quickly, and I don't need to do the whole thing. So I've got a 3 by 3 multiplied by a 3 by 1. The inside numbers agree, and you'll get a 3 by 1, the outside numbers. So what goes in this first entry? Well, that's row 1, column 1. And I'm going to have 1 times -9 plus 1 times 1 plus -3 times -1. And -3 times -1 is +3. So this is going to be -9 plus 4, which is going to be -5. And then I'll have an entry here and an entry here. But look at the selections. It's going to be that one. Okay. Now that's all well and fine. You can put those into your calculator, define them, and then do A inverse times B. All right, so I will do that for you. as well. So get into the matrix, second x inverse. We go to A. A is a 3 by 3. And 5, 4, 1. Okay, and that looks good. Get out, get back in. Now I'm going to go to the editor and I'm going to scroll down to B. B has 3 rows and 1 column, so it's a 3 by 1. I'm just going to overwrite -9, 1, and -1. Okay, so now get out. And I want to do A inverse times B. So get into the matrix menu. Under name, select A, and then X inverse, then times, get back into the matrix menu, and under names, select B, and then press enter. And there we are, answer A, okay. Selection A. Okay, we are on the last question, yay! Find the inverse of that matrix. Okay. I'd use my calculator. Again, the hand calculation is going to take a long time. What you cannot do is just take each of these numbers and take its multiplicative inverse. You know, take 1 over 1, 1 over 6, 1 over... It's going to lead you straight to the wrong selection, which is A. So, yeah, and the way you calculate it takes a long time. I mean, you have to set that up. Ugh. And then do row operations until you get the identity matrix over here. And then what you get over here is the inverse. All right, now that takes a long time and is prone to error. So how about we just put this in our calculator and we ask it for the inverse. And if the inverse doesn't exist, we'll get an error message. So Bob's your uncle. So let's get into the matrix menu. Go over to the editor. I'm going to call it A. It's a 3 by 3. So 1, 6, 1, 2, 2, 1, and 2, 5, 1. Okay, and I'm going to get out. Well, let me just double check I did it. Okay, get out, second mode, get back in, then under names I'm going to choose A, and then I'm going to do X inverse, and then I'm going to press enter. Okay, now it's okay because we can convert the decimal into fractions. You come here and find the math button and press enter, enter. There's the inverse. Okay. And you can see that that matches up with selection D. So the answer is D. Okay, we made it. And what is our time? 1 hour, 38 minutes, and 19 seconds. Okay, this is a 2-hour final exam. All right, usually it takes me less than an hour, but you know, I've been yapping and explaining and stuff like that. Okay, so I hope this sample exam for the university that I work at is helpful for the university where you're attending now, and I'm going to sign off for now. Thank you for watching the video if you made it all the way to the end with me. I'm Dr. Sooze. We'll see you next time.